So this is the video about dividing by unit fractions. And before we can get into the process of dividing by unit fractions, we have to come up with a consensus on what two important terms mean. The first, as obvious as it might seem, is what is division? What does the expression 12 divided by 4 actually represent? And what concepts are we using? So go ahead, pause the video, come up with a few ideas for what division really means, different ways, at least two different ways if you can think of them, of how we could imagine division. And then come back when you're ready to move on. So we're going to hold that question for just a second because the second part of things that we need to understand is what a unit fraction is. And a unit fraction is just a fraction that has a numerator of 1. There are lots of fractions like that, 1/2, 1/5, 1/32, 1/21. If you have a fraction where the numerator is 1, the denominator is an integer, then you have what's called a unit fraction. So that's what we're talking about division by today. And now let's get back to what division actually means. We can think about it in a few different ways, but one way you might have come up with for 12 divided by 4 is splitting into equal groups. And we can do that by splitting into either 4 equal groups, like we could in the rows of this array of apples, 4 equal groups of 3. Or we could split it into groups of 4, which is in the columns. Related to multiplication, we use arrays when we first learn about multiplication. Division can be thought of as the columns and the rows of the arrays when we're splitting into equal groups. So either groups of 4 or 4 groups. Either way satisfies the division idea of splitting into equal groups. Now that is great when you have whole numbers, and especially when the groups divide evenly into the dividend. But that doesn't work quite as well when we have fractions. So when we're dealing with fractions, especially with unit fractions, but with any fractions, we are going to look at this as how many 4s do I need to make 12? Or how many divisors make up the dividend? Divisor, dividend. So in doing that, we come up with an idea that 12 divided by 4 is how many copies of 4 we need to make 12. And that concept of division is going to allow us to understand how division by fractions happens. So let's think of a watermelon. And let's say this watermelon, we want to split this watermelon into fourths. Now this one whole watermelon, we can think of that process of splitting it into fourths as dividing and thinking how many fourths of a watermelon do I need to make a whole watermelon? Or what's 1 divided by 1/4? One watermelon split into equal groups of 1/4. Go ahead, pause the video for a second, see what you think. How many fourths of a watermelon do you need to make a whole watermelon? And then unpause when you've got that idea. Come back when you're ready to see the answer and move on. So this question may seem a little bit silly. You split a watermelon into 4 pieces. You're going to have 4 fourths of a watermelon because one whole watermelon is equal to 4 fourths. 1, 2, 3, 4. So one watermelon split into equal fourths is 4. This is a true division statement. 1 divided by 1/4 equals 4. Let's see another example of how that works, this time with a mile on a road. And let's say you wanted to run that mile, but you wanted to stop every 1/5 of a mile to walk for a little bit or catch your breath, or just because you're doing some repeats in 1/5 of a mile segments. And so the question could be, how many times do you need to run a 1/5 of a mile to make up 1 complete mile? Or what's 1 mile split into 1/5 mile segments? Go ahead, pause the video, answer this question for yourself in your notebook, come back when you're ready to see the answer and move on. Well, much like the watermelon example where we have a single watermelon split into fourths, a single mile split into fifths gives us, perhaps obviously, 1, 2, 3, 4, 5 fifths of a mile. Because one whole value is made up of 5 fifths. So split 1 into 1/5, it takes 5 fifths to make 1. How many 1/5 mile segments do we need to build a complete mile? That's how we're thinking of division. And to see how this works in terms of a process we can use for any old division problem we have by unit fractions, we're going to think about not running 1 mile, but running 4 miles. So if you're going to run 4 miles in 1/5 mile segments, How many times do you need to run that fifth of a mile, not to make 1, but to make 4? Go ahead, pause the video, see what you can do with this, come back when you're ready to move on. So in this case, when we're looking at 4 miles, we're not saying what is 1 divided by 1/5. It's breaking down 4 into 1/5. And the way we can think about this is that 4 breaks down into 4 ones, right? 4 is the same as 4 copies of 1. Each of those ones that we saw before is made up of 5/5. So the total number of fifths of a mile, 4 divided by 1/5, is not just equal to 5/5 to make 1 mile, it's equal to 5/5 times 4. So 4 divided by 1/5, well, each one of those 4s has 5/5 in it, and so our answer is you need to run it 20 times, because it takes 5/5 to make 1. That's where this part of the problem comes from, and we have 4 copies of 1. So what you might have noticed in all of the previous examples, 1 divided by 1/4, 1 divided by 1/5, 4 divided by 1/5, is we ended up using the denominator and making copies of that. Because if we think about 1, we can split 1 into as many different pieces as we want. We have 2 halves, we have 3/3, we have 27 27ths, we have 39 39ths. We can do whatever we want with 1 as far as a fraction is concerned. When the numerator and denominator are the same, we have 1 complete value. So if we're looking at the unit versions of these fractions, 1/2, 1/3, 1/27th, and 1/39th, we can say how many copies of 1/2, for example, does it take to make 1? Well, it takes 2, because we need our numerator to be the same as our denominator. How many copies of 1/27th does it take to make 1? It takes 27, because 27 27ths are equal to 1. So for every 1 whole value, we have a denominator's worth of copies. And that's how we get to our process for dividing by unit fractions, where when you divide a number by a unit fraction, you multiply that first number, the dividend, by the denominator of the fraction. So 5 divided by 1/7 on the right, for example, is the same as 5 times 7. Each of those 5 whole copies contains 7/7. So 7/7 times 5 gives you 35/7 in total. Go ahead, pause the video, write this process down, write down the algebra as well, and the numbers. Come back when you are ready to see an example problem, then do some practice problems for the end of the video. So the algebra on the left is just telling us not that we have to have variables for it, but that any numbers we would choose, the number n, whole number or not, divided by a unit fraction, 1 divided by a, where a is whatever denominator the fraction happens to be, is actually the same as n times a. Because this numbers example over here only tells us that it's true for 5 divided by 1/7. The algebra says it's true for any number we choose. And it can be for fractions, it can be for, n can be fractions, n can be decimals, n can be whole numbers, anything like that that you want. So we could do a process of 3/4 divided by 1/2. We're splitting 3/4 into equal groups of a half, and even though we don't have a full value here, 3/4 isn't a whole number, each whole number still contains 2 halves. So if we take 3/4 of a complete value and 3/4 of 2 halves each, we end up with 6/4, or that 3/4 divided by 1/2 is 3/2. It takes 1.5 halves to make 3/4. Just take a unit fraction, multiply the dividend by the denominator, and that's how you find out how many copies of the unit fraction we need to make the denominator. So go ahead, pause the video, work on these 4 problems here, come back when you are ready to see the answers. So in the problem in the upper left, we have 5/7 divided by 1/14. That becomes times 14 over 1. I'm going to use the trick we learned earlier about canceling before you multiply, and that gives us 10. It takes 10/14 to make 5/7. In the upper right-hand corner, we have 8/15 divided by 1/5, so that's 8/15 times 5 over 1. Again, let's cancel first. That's a 1 and a 3. So the quotient is 8/3. It takes 2 2/3, almost 3 copies of a fifth to make 8/15. Not a whole number of fifths, but some fraction of a fifth. On the bottom left here, we have a whole number divided by 1/20th, which means because we're multiplying, we need to convert it to an improper fraction, 11/5 times 20 over 1. Again, let's simplify before we multiply. A 4 and a 1, which means that 11 times 4 is 44. The denominator is 1, so it takes 44/20ths to make 11/5. And the same thing down here. For the last one, 11 over 9 times 21 over 1. Let's simplify first, divide by 3 to get 7 and 3. And so our answer is 77/3. It takes quite a few 21st, 21 to begin with in that first whole number, and then quite a few more to create 2 9ths. So this is the process for dividing by unit fractions. Divide by unit fraction, you multiply the dividend by the denominator of the unit fraction. That will help us in class to understand what it is that means to divide by non-unit fractions or just regular fractions. But that is the first half of that lesson.